This video is sponsored by PCB Way. Hello, Randy Rain here, and my maker friends often ask me, how do you make a motor go one way and then go the other way? Well, there's several different ways, actually. There are ICs that you can use that do that exact thing. I've used them before on my channel. They're okay for some applications. You can also use a DP-DT relay switch, but yuck. Or you can make what I'm going to show you how to make now, an H-Bridge circuit. Now, if you're worried about making the circuit, well, don't, because me and the sponsor of this video have got you taken care of. I've created 3 different circuit boards, and they're all ready to go at PCB Way. All you have to do is click the links below, and you're there and ready to go. Only people I actually use sponsor my videos. And PCB Way makes great PCBs, 3D printing, and they have CNC and so much more. So don't worry about making the circuit. We got you covered. Let me show you how it works, and then you can choose which one is best for your project. So to understand an H-bridge circuit, you need to understand bipolar transistors. To understand bipolar transistors, you need to understand the diode. To understand the diode, you need to understand semiconductors. So that's a lot to get through, so hang on. If you take silicon and you put in phosphorus, what happens is it gets an abundance of electrons. And since electrons are negatively charged, this is considered negatively charged, and we call it an N-type. Now, if you take silicon and you mix it with boron, what happens is it ends up missing electrons. It has holes where electrons can go, and we call that positive, and that's now a P-type. And if you take these two and you stick them together, and then you stick a wire here and a wire here, you've now made a diode. So now basically you have this negative charge, which has a whole bunch of electrons in it that are negatively charged. Over here you have these positive, which are a bunch of holes for the electrons to fall into. If you have a battery, and this is positive and this is negative on your battery, and you hook it this way, here, this negative's coming up here, and it hits here, and it's able to jump over. Because basically what happens is this negative charge comes in here, it's pushing these like a same charge pushes on a magnet, and it forces them over. And same with the positive, it's forcing the holes, and it allows them to get here and jump across. Now if you reversed it, and you had the negative battery going up here to the positive, right? And you had the positive going over here to the N, well, what happens is it does the opposite. Then pulls the electrons out here, right? And over here, it pulls the holes out over here. And so there's no connection here. So this has no connection. So a diode is a one-way valve, basically. Electricity can flow one direction, it can't flow the other direction. So let's say you have up here, these are N-types, and then you put a P-type in the center here. Well, that's one kind of transistor. You can come over here, and we can do a P and a P, and you put it in here. And so these are the 2 types of bipolar transistors, NPN and PNP. So let's look at this one. One of these is called the emitter, one of these is called the collector, and this is called the base here. Now with this one, since this emitter is negative, you would run this to ground or to negative. And the way a transistor works is, I could say, is if you put a positive here on the base, it'll allow negative to come out here. That's one way to look at it, but really look at it like this. If a little bit of electricity, a little bit of negative electricity can go through here and come out the base, a lot of electricity can go through the emitter and come out the collector. If you stop the electricity coming out of the base, you stop the electricity coming out of the collector. So how do you make this come out the base? Well, you put a positive here, right? Like that. So here you have negative and positive coming together. But if this was a battery, you're essentially just shorting out your battery, right? Because negative's coming up here and positive's going to there, and if that was a battery, it's going to get very hot. So what you have to do is you have to put a load. So what you could do is you could put a light bulb right here, right? A light bulb. Okay, and so when the negative comes up here, this side of the light bulb gets negative, this side of the light bulb gets positive, and that will make the light bulb shine up. And at the same time, that will make electricity come out the collector. But you don't want to be changing out light bulbs all the time. That's pretty dumb. So instead, just put a resistor here. And the resistor will act as the load, just like the light bulb will. And so we'll just say it's a 1K resistor. That usually works. So as long as we have this negative coming out here and going to this resistor, and we have a positive going to the resistor, that allows it to come out the collector. Now it's the exact same thing over here, just backwards. Here you would put a positive charge, and you would have to ground it here. But you can't do that, so you better put a resistor here for a load. And so now, if positive can come out of that base and go to that resistor, then positive can come out the collector out here. And so if you put a positive charge here, and you put a negative charge here, right? What will happen is this will come out negative, and that will come out positive. As you have a motor right here, well, you just run it to here, you run that to there. So if you put a negative here, the positive comes around, motor gets positive there. Put a positive here, negative comes around, and this side gets a negative, and the motor spins in one direction. Let's see this in action. Here's an NPN transistor. Now I'll put my PNP over on this side. Now my PNP, the emitter, has to be jump positive. I'll use this side over here. It's 5 volts. My emitter on this one has to be connected to ground or to negative. I'm just going to use some 1K resistors. And then on the collector here and the collector here, this goes to the motor. This one here, it's supposed to go to negative, and then this one should go to positive. All hooked up, all I got to do is turn it on, and you can see it comes on. That's really not all that helpful yet. Let's say you want to turn this on with one positive charge. Well, what you need is another one of these NPN transistors. And you'd put it over here. This goes to ground, okay? This goes up to here. You put your resistor here. And now this right here and this right here can be connected. And so what's going to happen is positive turns this on, allowing negative to come over here. Positive turns this on, allowing negative to come up here and turning on this. And now that's positive. Now there can be a problem here that as soon as you take electricity off here, this one gets stuck. So to fix that, you add another resistor, we'll say a 10K resistor, a big one, and that goes to positive up here. That's called a pull-up resistor. So let's see this in action. And so now, if I turn this on, all I have to do is put positive to here. Positive is going to go to this 2N3904, turn it on. It's going to allow a negative to come over here to turn this one on, and that's going to run a positive to here. And this positive is also going to go over to here, turn this one back on, and give me the negative for the other side. So here we go. Just one. So now I hope you see where we're going with this. Because what we can do is build another one of these right here. And so now up here, all we have to do is go across like that. So now, if you put positive here and these two are the same, it makes the motor go this way. But if you take up the positive here and you put it on this input, for these are connected, well, now you've switched it. So now this is positive and this is negative. And so that's how you can switch the motor back and forth. Let's see this in action. Here's a 2N 222, 2N 907. Here's a 2N 3904. Bring this one to ground, this one to positive. Base over to there for now. And we'll put this base with a resistor over to here for now. We need to put the emitter of this guy to ground. We'll connect these two inputs here. Our pull-up resistor. We'll take this one. Here's our motor outputs in blue. This is one input. This was our original one. If it goes positive, it turns that direction. Here's the other one. If it goes positive, it goes the other direction. And of course I can do them over here on the 3 volts. That one goes that direction. That one goes the other direction. As long as the grounds are connected, I could do a whole different power source. So this can turn it that direction. This turns it the other direction. So there you go. That's it. That's all you have to do. Nothing else. That's it. Nothing more. I'm just kidding. I'm just torturing people who are watching me explain this even though they already know all this. Hoping I mess up or something. I'm not sure. But yes, there's something I've left off here. And it's very important. You should put a capacitor right here across the motor. If you put a capacitor across the motor, it'll really help. I'm just kidding. No, seriously, you should put a capacitor across the motor, but God, if you only knew how much that made me laugh. Nope, there's something I did leave off here, okay? Motors are electromechanical devices, and they cause electromagnetic fields. They cause noise in the circuit. Just look at it like this. When you kill the electricity to the motor and it stops, to us it looks like it stops immediately, but if you look at it in microseconds, momentum takes it a little while for it to stop. In those few little microseconds, it is no longer a motor, it's a generator. And so it's generating electricity. And so it can put electricity back into your transistors and stuff. And that can be a problem. So the solution, you remember the little diode that I showed at the beginning? Well, what you can do is you can say, like, here are 2 points right here that are going to the motor from each one, okay? What you could do is you could put a diode here. There's a line on a diode. That's the side that negative gets, okay? So negative would go this way, and so you'd put it to ground like that. Now, negative cannot go that direction. So this negative is not going to help that motor. But if that motor generated a negative charge, it's going to go out to here. And you can do the exact same thing like this, where it goes to positive. Now, if it generates a positive charge, it can go this way safely to positive. But positive cannot go that way. Same thing over here. Do it to here as well. You have this one would go to negative, and you'd have another one that would go to positive, and so forth. And so it would safely exit, and you wouldn't put the electricity going backwards through your electronics. And that is what an H-bridge circuit is. And you can see it's because it looks kind of like an H. So now we're back to the beginning, and you don't even have to make this circuit. I've already done it for you, and I have 3 different sizes. I have a small one where it just uses regular transistors and it will handle small motors. I have a bigger one that's the exact same thing. It just has bigger traces and uses bigger transistors. Then I have a dual motor control where it does 2 motors. Now instead of using the 4 extra transistors, I went with the chip. And that's because that circuit is called an inverter. And you can get chips that already have that exact circuit on there. And that saves me from having to make them. And you should find links to these below. Well, I hope you learned something from this video, and if you did, I sure would appreciate a thumbs up. If you want to see more stuff like this, hit the subscribe button. I want to thank these people here. These are the patrons. These are the people bringing you this stuff, and I thank them oh so very much. I couldn't do any of this stuff without them. So if you'd like to help out, there are some perks, so there are links, and check all that out. Anyway, thanks for watching. These are film.